Lecture 1.6, Trig Functions. This photo is of the Black Canyon of the Gunnison National Park in Colorado. The photo was taken by Vicki Kelly in 2008. This canyon is so narrow that some parts of the river only see the sunlight for a few minutes at midday when the sun is directly overhead. Trigonometric functions are used extensively in calculus. When you use trig functions in calculus, you must use a radian measure for the angles. To check or change the angle mode, press on 5, which is settings, 2, document settings. Make sure you set the angle mode to radian and then scroll down and click Make Default. You could also click Restore, which returns the calculator to the factory settings, which include radian mode, and then click Make Default. The best plan is to leave the calculator mode to radians and use pi degrees when you need to use degrees. To find trig functions in the TI-nspire, press Trig, select the desired function, and press Enter. If you want to brush up on trig functions, they are graphed in your book. Even and odd functions. Even functions behave like polynomials with even exponents in that when you change the sign of x, the y value doesn't change. Cosine is an even function because the cosine of negative theta equals the cosine of theta. Secant is also an even function because it is the reciprocal of cosine. Even functions are symmetric about the y-axis. Odd functions behave like polynomials with odd exponents in that when you change the sign of x, the sign of the y value also changes. Sine is an odd function because sine of negative theta equals negative sine theta. Cosecant, tangent, and cotangent are also odd because their formulas contain the sine function. Odd functions have origin symmetry. The rules for shifting, stretching, shrinking, and reflecting the graph of a function apply to trigonometric functions. We looked at this standard form earlier. Remember, the A in the front causes a vertical stretch or shrink, or reflection about the x-axis if A is negative. The absolute value of A greater than 1 makes a stretch. The coefficient inside the parentheses causes a horizontal stretch or shrink, reflection about the y-axis, and if the absolute value of B is greater than 1, it's a shrink. The constant added inside the parentheses adds a horizontal shift. A positive value of C moves the graph left. And a constant added at the end causes a vertical shift. A positive value of D moves the graph up. The horizontal changes happen in the opposite direction to what you might expect. When we apply these rules to sine and cosine, we use some different terms. We'll write f of x equals a sine the quantity 2 pi over b times the quantity x minus c with a plus d added at the end. And I've drawn this graph to illustrate what we mean. The absolute value of a at the beginning of is the amplitude, and the amplitude is the distance from the center to the high point or the center to the low point. The absolute value of b is the period, and the period is the length of one cycle. The C inside the parentheses causes a horizontal shift, so minus C moves it to the right. And the D at the end causes a vertical shift, so the center line has been moved up a distance D. This particular equation is y equals 1.5 sine 2 pi over 4 times x minus 1 plus 2. Trig functions are not one-to-one. It would fail the horizontal line test. However, the domain can be restricted for trig functions to make them one-to-one. These restricted trig functions have inverses. Inverse trig functions and their restricted domains and ranges are defined in the book.